In this video we will be looking at the most popular screens to use with meters. We have a virtual meter model. All meters that are integrated into PNP SCADA are integrated into this model. We have totals, profile, events, phasors, instrumentation profile, billing registers, relays and breakers, real-time, and STS prepaid. Totals are your monthly totals that can be used to calculate bills on basic tariffs such as inclined block tariff. You typically only need one total at the start of each month, however there can be many totals read during a month. There are 6 totals that we read. E1, or forward active energy. This is the main total that most people know of, measured in kilowatt-hour. E2, or reverse active energy. This is the total of all the electricity that was pushed back into the grid, such as when solar is involved, measured in kilowatt-hour. So here we see that when electricity flows backwards, it does not subtract from the main register, rather it gets added to a separate register. F1, or forward reactive energy. Reactive energy is like wasted energy. Imagine standing behind a car to push it. All your energy goes into pushing the car forward. Now imagine standing at a 45-degree angle behind a car to push it. Only some of your energy goes into making the car go forward. But some of your energy goes to waste. This is measured in kilowatt-hour. F4, or forward reactive energy with leading power factor. Most machines like electrical motors cause electricity to become inductive or have a lagging power factor. However, there are devices like fluorescent lights that cause the electricity to become capacitive or leading power factor. F4 is the total of reactive power used when the power factor was leading. This is less often the case, and thus many municipal tariffs do not even look at reactive power with leading power factor. It is, however, in some cases needed and is therefore read from the meter. F2 and F3 are the same as F1 and F4 but for reverse solar power. Residential meters typically only log E1, and commercial and industrial typically only log E1 and F1. All 6 of these registers are typically only logged in heavy industry. When all 6 of these registers are logged, it is called 4-quadrant metering. There is a standard that tries to formally name all of the different types of registers available. These codes are called OBIS codes. The OBIS codes for the registers explained above, E1, 1.8.0, E2, 2.8.0, F1, 5.8.0, F2, 6.8.0, F3, 7.8.0, and F4, 8.8.0. You don't have to remember these codes, but they do sometimes come up when dealing with meter readings. Next we have profile. Profile is typically stored as a reading per half hour. So in one day you'll have 48 half-hour readings. It is different to totals, in that it starts counting from 0 at the start of each half hour. Profile is integrated into half-hour slots, and totals accumulative, they just keep adding to last month's reading. Also note that profile can be logged into other intervals. For example, water is often only logged as one reading per hour. And in some countries electricity is profiled in 15-minute intervals. Profile logs the same 6 registers as totals, but it is called P1, P2 and Q1 to Q4. Let's quickly talk about the difference between kilowatt-hour and kilowatt. Saying I traveled 120 kilometers per hour is not the same as saying I traveled 120 kilometers. Similarly, kilowatt is the speed at which you use electricity, and kilowatt-hour is the amount of electricity used. On a bill you will always find kilowatt-hour. Kilowatt on a bill does not make sense. It is a bit confusing that the one with the H is not the speed one. That being said, often when kilowatt is given, it is actually the average kilowatt over the integration period. In this case you can convert between kilowatt and kilowatt-hour. So just as traveling an average of 120 kilometers per hour for an hour means you traveled 120 kilometers, so too, using electricity at an average of 10 kilowatt for an hour means you use 10 kilowatt-hour, or 5 kilowatt-hour per half hour. Let's also look at maximum demand. Maximum demand is measured in kVA, and is therefore sometimes called kVA. It is also sometimes called just demand. Here we see a graph of the profile data for a month. The gold is the consumption, and floating on top of it we see the demand in purple. Maximum demand is the highest peak for the month. We see the highest peak here. The demand is always given as a kVA value with a date and half hour when it happened. The OBIS code for demand is 9.6.0. When the demand is floating far on top of the consumption, then the consumer has a bad power factor. Power factor correction equipment can be installed to bring the demand down to the consumption. Back to profile and totals, it is necessary to note that the usage for a month can be calculated in two ways. 1. You can take the month-end total minus the month-start total. 2. You can take the sum of all the half-hour profile values for the month. Both of these should come to the same usage. If they don't, then you have an audit error. There is a video about audits if you would like to understand more about that. Next we have events. Smart meters can log many types of events. For example, when someone opens the meter, a tamper event is logged. When someone reprograms the meter, a reprogram event is logged. When the power goes down, or there is a spike in the voltage or currents. Some of the events might not come from the meter, but from the system and is logged against the meter. Like when the profile and totals are read from the meter and they don't match up, an audit error event is logged by the system against the meter. One of the primary value adds of smart meters over manual meter readings is events. With manual meter reading, you need to wait to the end of the month before you can pick up on tampers or pipe bursts. But with smart meters, this information can be monitored on a daily basis. It is therefore important to pay attention to these events before running a bill. If you do not look at events, then your product offering is not going to be much better than manual meter readings. Before we look at the next one, which is phasors, let's look at the types of meters. Meters typically come in either single phase or three phase. Single phase is typically used by residential and commercial consumers, and three phase is typically used by heavy commercial and industrial consumers. Three phase meters come in a couple of categories: 100 amp direct connect, 5 amp CT meters, CT and VT meters. CT and VT meters with 3-wire installation. CT stands for current transformer. Large amounts of electricity cannot be pushed through a meter as the meter will break. So to get past this limitation, manufacturers use CTs. A CT transforms a big current into a small current, to something that the meter can handle. A CT comes with a ratio. For example, 600 to 5. This means that it transforms 600 amp into 5 amp. The meter then reads 5 amp and uses the ratio to get to 600 amp. This process of using CTs to make the current small, and then programming the ratio into the meter, so that the meter scales it to the correct reading, is called primary metering. Secondary metering is when CTs are used just like with primary metering, but the ratio is not programmed into the meter. So instead of storing 600 amp, the meter stores 5 amp. The system then reads those small values from the meter, and then needs to multiply the readings on the system side. The bigger of a current a CT needs to make small, the more expensive it becomes. Also, the bigger it is, the less accurate it becomes. For this reason, a CT is typically spec'd to be the same size as the breaker. So if a client has a 600 amp breaker, then the CT should also have a 600 to 5 ratio. That being said, let's look at the next one, which is phasors. Phasors are the instantaneous currents and the voltages over 3 phases. The power factor of each phase is also given as an angle between the voltage and current of each phase. Power factor is an indication of how good your electricity is. When there is a lot of reactive energy, then the power is considered to have a bad power factor. From the phasor diagram, it is possible to tell if an installation was done correctly. And if an installation was not done correctly, it is even sometimes possible to tell how it was done incorrectly. For this reason, it is usually a good idea to check the phasor data before your technician leaves the site. Next, we have instrumentation profile. Instrumentation profile is like the phasor data, but it is taken at an interval, usually every 5 or 10 minutes, and saved on the meter. We can then read these values and plot them on a graph. Instrumentation profile, however, can be more than just the voltages, currents, and power factor. Sometimes temperatures, or for prepaid, credit left might also be saved. Next we have billing registers. This is an extension of the 6 totals that can be read. In some cases, electricity might be more expensive during certain times of the day. This is called time of use. Time of use typically has 3 rates, namely peak, standard, and off-peak. The normal way for PNP SCADA to use time of use is to calculate consumption using the profile data. However, in some cases the municipality wants the meter to keep track of peak, standard, and off-peak. So there will then be a subset of the E1 total register for peak, and a second one for standard and a third one for off-peak. These billing registers can then be read from the meter and used in billing. The OBIS codes for time of use registers is usually peak 1.8.1, standard 1.8.2, off-peak 1.8.3. As a side note, the generator power is usually put into 1.8.4. The meter is told that the current power is generator power by a wire coming from the generator that gets pulled high. Next we have relays and breakers. Many single-phase meters come with the ability to programmatically switch a relay or a breaker on the meter. A breaker is typically a big switch that can switch a big load, such as 100 amp. Typically the breaker switches off the consumer. A relay is a tiny switch that is meant to switch a big relay. This is rarely used, but if you need to switch more than 100 amp, there is often no other option. Next we have real time. This is when we read values from the meter and give it in real time. Current running total, current kVA, current voltage in amps, etc. can be given on a per minute basis. This information can also be accessed using SNMP or OPC. Now that we understand what totals, profile, events, and phasors are, let's look at the different pages in PNP SCADA that deal with managing these sets of data. Let's first look at screens that deal with getting readings into the system. Edit meter details. This screen shows the meter's serial. Note you cannot change a meter's serial after it has been added. You can set the CT and VT ratio. CT should be 5:5 for direct connect. Breaker size and number of wires connected. 2 for single phase, 3 or 4 for 3 phase. Meter name is typically the consumer's name. Place, site, and zone are freeform and typically have some form of the address. Password is the password programmed onto the meter and needed by the system to talk to the meter. Multi-drop ID is needed by some meters that use this to address meters that are put on the same communication device. If the CT ratio was not programmed into the meter, in effect, secondary metering, you can apply the CT ratio server side by unticking primary metering and putting the CT ratio into multiplier. Disabled will prevent any more data from being added to this meter. Commissioned is used by some to indicate if the meter is currently in use. It is mainly only referenced by the problem meter list. Manual read only will prevent the acquisition thread from trying to read this meter. However, you can still go to Tools, Communication Monitor, and start a read manually. Installation date and time is the time the meter was commissioned. We also refer to this date as the COM date. When taking over a site where the meter was already installed, it is good to have the previous month's data. For this reason, put the installation date back to when the meter was really installed on site so the system can get as much of the old data as is available. Last read up to date and time is up to where the system has data for the meter. We also refer to this date as the max date. If you for some reason need to reread a meter, you can set this date back and the system will reread that data. Tick. Delete newer data. To also delete all data after the max date. Uninstall meter will add _old behind the meter serial, thus freeing up this serial to be used again on another client. Replace meter will do an uninstall and open the add wizard so you can add a new meter. Tenant move out will do an uninstall and recreate the same meter, so that you have a different meter for the new tenant. Edit, advanced meter settings. Firstly, you can change how frequently the data on the meter is read. Remember that even though the meter logs its data in half hours, the system typically only downloads this half-hour profile from the meter once a day. It is a good idea to read phasor data at 9 o'clock in the morning. Sample period is how long a sample of profile value is. 1800 is 30 minutes. This must match what the meter is set to. Here you can change which sets to read. and channels to ignore. Remember, a tick here means ignore the meter's time zone. Error streak is how many times the meter has failed to read since the last success. If this goes past error threshold, the system will stop trying to read this meter. This is good for when you have a batch of meters that you added to the system but have not yet installed on site, thus reducing load on the system trying to read a meter every 30 minutes that is not even installed. Once a technician installs the meter and a successful manual read is done under Tools, Communication Monitor, error streak is reset and the meter will continue to be read daily as usual. When the error streak goes past error degradation, the system will only try to read the meter automatically once per day. Register calendars has to do with reading billing registers from the meter and mapping them to calendar rates. Decimals and digits on bill change the total displayed on the bills so that it matches exactly what the meter's LCD shows. Reclock is the point where the meter total gets reclocked. If the meter's total goes up to 9,999 and then starts over at 0, then the reclock it should be put to 10,000. The next section deals with meter alarms. When these alarms are triggered, they are logged against the meter as events. Here are alarms for spike, consumption over limit, power factor, bypass, leak, burst, and over and under voltage. This does not change anything on the meter, and only analyzes the data coming in from the meter to generate these events, system side. Audit threshold causes the system to not log audit fails against the meter when the total consumption for the period is very small. By default, the system sets the meter's time when it goes out. You can change this behavior here. Sometimes, meter-specific values are shown at the bottom of this screen. Tools, Problem Meter List. This screen shows a list of all the meters that have not been read in, up to today. The meters that are the furthest back are listed at the top of this list. First, the serial is shown. Then the date, up to where the meter has data. A quick list of meter accounts linked to this meter. Phone number. A short description of the problem. What sets still need to be read. And a follow-up note that gets logged under the fault log. If you have meters that you are not reading anymore, but you still want them on the system, you can disable them under Edit, Meter Details, Disable. That will remove them from this list. If a meter is not listed here, but should be, it might be that it is not commissioned. However, we recommend not using this flag. It is good to keep this list clean. If you manage only a couple of meters, it might be okay to check this list a day or two before bill run day. But if you manage hundreds of meters, it might be better to have someone look at the problem meter list every day. A list of some of the more common problems can be found under Help on this page. Tools, Fault Log. Here we see the open faults that were logged against a meter. You can go to a fault and fill in the form. To close a fault, click Cleared and then Submit. This will also take the fault message off the problem meter list. Tools, Communication Monitor. Here you can tell a meter to read in now. The communication between the server and the meter is printed here. Blue is the server talking to the meter, and green is the meter's response. You can tick which sets you wish to read and then click Start Read. If you don't see a tick that you think should be there, you can check under Edit, Advanced Meter Settings, if it has not perhaps been disabled. Stop Current Read will attempt to stop the current reading meter. Close Connection will attempt to close the current connection to the meter. Queue State will show the acquire queue's entry for this meter. This meter might be part of many meters connected to the same modem or server, in which case the current information displayed might be for a different meter on the same modem. Clear Output clears this screen. Removing auto scroll will cause the screen to stop scrolling by itself. Debug mode will switch to showing the debug output of the driver instead of the communication between the meter and the server. This is sometimes more helpful in finding a problem when a meter does not read. Errors are highlighted in red to facilitate finding errors. Logs will take you to the meter read logs. The acquisition of data from the meter goes through 3 stages. Stage 1 is reading the data from the meter. Stage 2 is putting that information into the database. And stage 3 is the acquisition thread, checking that the read was successful on all sets. All 3 of these stages must be successful before a meter is read correctly. Here we see success on the read stage of the meter. Here we see success on the output into the database. And finally, a success from the acquisition queue. It could happen that the system could not read all the data from the meter, but just a little bit of data. In such a case, the first stage will still show success, but the later stages will fail. So you need to see success on all stages before determining that the meter is reading. Tools, meter read logs. Here we see every attempt made by the server to read the meter, as well as the outcome and a technical description. Max date is the date up to where the system has data for a meter. Prior max date is up to where the system had data for a meter when it tried to read the meter for this attempt. From this you can sometimes see that even though a meter is connecting, the max date never moves along. Raw data is just a download of the communication between the server and the meter. This is sometimes useful to see that the meter actually never replies, in effect, no RX, pointing to a problem between meter and modem. Or that the meter does reply, but after a very big RX the conversation drops, pointing to bad signal. Next we look at meter totals. Edit meter totals. This is the primary screen to manage totals. Here we have the totals shown in rows. First column is time, then E1, F1 or quadrant 1 reactive, E2 export or solar, F3, F2 and F4. Then we have the status. The status is explained at the bottom of this screen. Status 1 is calculated, 3 is read from meter, and 9 is captured manually. Each value corresponds to a register. The last one is for the first register, U1. And the second last one is for the second register, F1. The 7th digit indicates check totals. A check total is a total that is not on the half hour, and thus cannot be used for billing purposes. Next we have active reading, which is a copy of the E1 register found under active import. However, it is before any reclocks or multiplications have been done. This column is the one we put on the bill. For you to be transparent to the consumer, you need to put the meter's total on the bill. The consumer can then take a picture of their bill, maintaining proper safety, and compare that with what is on the bill. For this reason we made every effort to show the total on the bill as it would be on the meter. You can even set the number of digits that must be displayed on the bill under Edit, Advanced Meter Settings, digits of total on bill to match the number of digits on the meter's LCD display. Reactive reading is the same but for the F1 register. In the last column there are options to delete, interpolate and recalculate. Delete will not show on totals of status 3 because they were read from the meter, and if you delete them, they will probably be put back the next time you read the meter. Interpolate and recalculate, as well as the 2 buttons to reinterpolate all and hide check totals, are used with audits. There are many videos and articles on the wiki about audits. Please watch those videos if you have questions about audits. At the top is the audit threshold. This allows you to specify how much the profile and totals need to match up before an audit fail is reported. Audit fails are shown in the colors described below the table. There is also a link to enter manual readings. You can click this link and then enter the total you want to add. You will have the option to choose between scaled and unscaled. Scaled is when the reading was already multiplied by the multiplication factor under Edit, Meter Details, Multiplier. Unscaled means the reading you just entered needs to be multiplied by the multiplication factor before inserting. Then click Set to insert the total. View Meter Totals is a screen that you can give to clients that you only want to give viewing rights to totals. It has many of the same columns as the Edit screen, however it also shows when the total was read. Tools, Bulk Capture Manual Readings, allows us to capture totals in bulk. It lists your meters per row. It shows the last total as well as when that total was taken. Here you can insert the total that you want to capture for this meter. Above the table is a place to enter the date for which you are capturing the totals. You can click on Create to capture the filled-in totals. You can also estimate totals by ticking the ones you want to estimate. Or click on the heading. or click and shift-click to extend. Then click Estimate. By default, this list only lists virtual and manual read-only meters. If the meter is not listed here, you can switch on manual read-only under Edit, Meter Details. At the bottom of this screen is a way to upload a CSV file. The data is then populated in this screen, and you can then click Create to upload the readings. Tools, Bulk Capture Manual Electricity Readings. This screen is the same as the previous screen, except that it has a column to upload your F1 total and your demand. Tools, Total Validation. This screen also allows you to capture totals. It does try to compare the current total capture with previous month's totals. Therefore, it starts off by asking for a date range, and not just a date. We can also choose which meters to have in the list. First column shows the meter serial, then meter name. Then you have the consumption for 4 months. This column shows the total for last month. And then you have a place to capture the current total. Worst variation compares this month's consumption with the previous 3 months and gives the worst variation as a percentage. There is also a column to capture notes. A link to open faults on this meter. Images uploaded against this meter. You can upload images under Tools, Upload Meter Reading Photos. You can set these photos to display on the provisional bill under Edit, Meter Account. Show more options, display event files below monthly bill. There are other screens that deal with totals, however these are the main ones. Next we have Profile. View Profile Graph. Here we see the profile in the context of the tariff. If the tariff has time of use enabled, then the graph will also show as time of use. If the tariff has demand, then the graph will also show demand. You can change the date you are looking at by clicking on Choose Dates. You can also navigate by using page left and right. If you are looking at a full month, then page left will go 1 month back. If you are looking at a week, then it will go 1 week back. Similarly, pan left will go 1 day left if you are looking at a week or month, and only half an hour if you are looking at a day. Zoom out will snap to day boundaries if you are not on day boundaries. Then it will zoom out to see a week, then 2 weeks, then a month, then 3 months, and finally a year. If you can't page left or right, that is because you have reached the end of the data. In the first week of the month, the graph defaults to showing last month's profile. For the rest of the month, it shows this week. Above the graph, you can get an error if the tariff is not valid. And a black graph means no profile is available for the period you are looking at. You can switch between meter accounts with this drop-down. If you have more than 100 meter accounts on your system, then this drop-down is not available anymore. If you have multiple tariffs linked to the meter account, you can switch between tariffs for a quick tariff comparison. You can hide some of the lines on the graph. You will notice that consumption is shown as bars, and demand is shown as lines. This is because demand is better compared to average kilowatt than to kilowatt hour. By drawing the consumption as a bar, the height of the bar is kilowatt and is comparable with kVA. And the area of the bar is kilowatt hour. So you get kilowatt, kilowatt hour, and kVA on the graph. Here we see the consumption that you are looking at, calculated from profile. If the tariff includes reverse energy, this will show the net metering instead of consumption. And demand if in the tariff. Note that this is the pure demand regardless of any time of use calendar. Below the graph is a provisional bill. If you page or pan, the bill is hidden. To show it again, click Refresh Graph. You can print the provisional bill to PDF by right-clicking on the bill and choosing Print. Then set destination to Save as PDF. View Download Profile CSV. You can download the profile you are currently looking at by going to View, Download Profile CSV. You will get a spreadsheet with the date and the half-hour readings in one column. View Meter Graph, another screen where you can view the meter profile. This screen does not show it in the context of the tariff. The phasors and events are also shown below the graph. Tools, Import Readings. You can import profile data from this screen. There is a video on how to import profile and totals. This screen also works for uploading profile for multiple meters at once and is also used to configure some of the FTP upload settings. Next we have events. View meter event log. On this screen we see all the events logged against this meter. We see the start and end date of the event. Then the event class. Then a short code of the event. You can hover your mouse over the short code to get the full name. Then the phase to which the event applies. If a value was specified with the event, it is given here. Validated is N for events that causes the meter's data to become invalid for billing purposes. You can control which events cause the data to become invalid for billing purposes under Edit, Meter Event Setup. This shows a long list of all events that the meter can log, as well as all events that the system can log against the meter. The first column shows the event and then the short code. Event class and source can be either meter or system. Invalidates is whether this meter's data becomes invalid for billing purposes when this event is logged against the meter. It is important to set up this column according to your needs, or else you might have to validate a lot of unnecessary events on bill run day. Notification will send this event to your inbox when it is logged. Remember that these settings are per meter. You can set it in bulk under Tools, Bulk Edit. Generate notification when event stops. And combine events when overlap. View Bulk Event Report. Here you can get a bulk list of events over multiple meters. You choose which meters. The system will then show you a list of all events found for those meters. You can choose which events you are interested in and submit. At the bottom of this screen you can then mark these events as valid in bulk. Tools, Meter Validation Screen. This is the first step in running a bill. You can choose which meters to validate and then click Submit. A blank submit will return all meters with invalid data. First column shows the meter and is a link to the meter's edit, meter total screen. Then the meter name. Then a comma-separated list of all the short codes of the events that cause the meter's data to become invalid for billing purposes. You can click on this link to go to the event log. Finally, a link to the profile graph. The profile graph is often the quickest way to see what is wrong with the meter's data. You can pick up on things like reverse CT, bypass meter, CT ratio incorrect, spike in data, and many more. Next is a link to the fault log. And then you have the option to mark the data as valid. Both buttons mark the data as valid, but the yellow one will allow you to log a message against the validation. Before the meter's data is marked as valid, an audit is done. This means comparing profile to totals. If the audit fails, the data is not marked as valid and you need to fix profile and totals first. Sometimes the audit fail is very small, so you can change the percentage difference between totals and profile. Next we have phasors. View phasor graph. Column 1 is the time that the phasor was read. Then we have the voltage over the 3 phases. Then volt angle. Currents including the neutral phase. Current angle. The active power calculated from the volts and amps. And then power factor. When the current is less than 5 amp, the phasor is typically not a good one to use. For this reason it is better to read phasors during work hours. You can click on the time to see the graph. From here it is possible to determine if an installation was done correctly. There are articles on the wiki describing what a correct CT will look like. Reports, phasor report. This shows the phasors over multiple meters. Show last 3 phasors is so that when a phasor was read during low amperage, that you can skip that one and rather look at a previous phasor. Next, let's look at the Edit Meter Account screen. A meter account links a meter to a tariff. Multiple meters can be added together to make a summation meter account. This will take the sum of the consumption of the different meters. A meter can also be subdivided into multiple accounts. So, for example, if a shop is split into 2, and each tenant agrees to pay half of the electricity bill. You can also add some meters and subtract others. So you can, for example, add the incomer meter and subtract tenant meters. What is then left is then losses and common area. Next, you can also link multiple tariffs to a meter account to do tariff comparisons. The tariff marked as the default will be used when a bill is run. Area of premise is the size of the property covered by this meter account. You can use it to let the system subdivide a meter among multiple tenants. Calculate portion will take the portion of this meter account against all meter accounts linked to this meter and fill it in under portion. Disabled is the vacant flag and indicates that this meter account should not be used in the portioning. Below is Show more options. Financial year start is used by some reports like the recovery report to know where the report should break up its years. Show a provisional bill on the profile graph screen just allows a user to see the provisional bill below the profile graph. This meter account is used for billing. Is used by some reports that only apply to meter accounts used for billing. Billing period is the reset date for the demand register. Typically, the demand resets on the first day of the month. If you then bill your client from the 23rd to the 23rd, then the demand will be calculated as 23rd to 30th. And another demand from the 1st to the 23rd. But if you set your billing period to the 23rd, then only the demand for the 23rd to the 23rd will be calculated. Run provisional bills separately. Allows you to run one bill over multiple months and see the sub-periods as individual sections on the bill. Send bill as PDF file attachment. Will send the bill to all logins that have access to this meter account when the bill is published. Attempt to run bill automatically. We'll try to run the bill on the first day of the month. It gives only 8 hours for the meter to be read and then sends an error report. Display the portion as the billing multiplier. We'll take the portion configured under Edit, Meter Account, and show it on the bill as a multiplier. Hide meters on bill. We'll hide the meters. This is useful for when there are many meters in one meter account. Number of meters on bill before it automatically hides. Will automatically hide the meters on the bill once the number of meters in the meter account goes past this amount. This is useful if you want to, for example, show all 30 meters in the meter account. Display event files below monthly bill. Will show the meter reading photos below the bill. Show all columns in CSV profile download. Will cause all columns P1 to Q4 to be inserted into the CSV download. By default, the system only puts in columns that contain data. This is useful for when you use these CSV files and scripts, and you need all the columns to be the same every time. Add new shift cost tariff. Allows you to splice the meter account with a calendar. This is useful to then compare night shift with day shift. Use browser's time zone. We'll use the browser's time zone to display the meter's data. This is the default. If you have a foreign investor that wants to see the data in the country that the meter is in, you can untick this. Then the meter's time zone will be used instead. Remove fractions of cents. Will ensure that the cents you see in the last column of the provisional bill will add up correctly to the cents in the total. By default, the individual line items are rounded to cents when displayed, so they don't always add up exactly to the total. Always smooth out provisional bills. Will portion fixed and demand charges according to the time span in the month that you are looking at. So if you are only looking at half a month, the fixed charges and demand charges will also be halved. Meter account sample period in hours is the number of hours per meter profile sample. If your meter logs profile in half hours, this should be half. If your meter logs one profile value per day, this should be 24. You now know totals, profile, events and phasors and the basic screens to maintain those sets. Thanks for watching this video.